Okay, I'm gonna go into tops a little bit here. But first of all, a really good thing to know when you're looking at your project and you want to start optimizing is, are you CPU bound or are you GPU bound? Which process is the limiting factor of your frame rate if you're not hitting 60 frames per second? So it's not too hard to find this out actually. So if you're CPU bound, I'm gonna make this process CPU bound. I have 4 channels here with 1,000 samples. I need more samples. Like let's try 10,000. Okay, I need more than 10,000. How about 19,000? Oh geez. Aha, 40,000. And now you can see that my cook time has gone up to 9 milliseconds, and I'm losing. So let me just check my task manager. All right. Now the TouchDesigner process runs on basically one thread. So you'll see that I should have somewhere around 100% if I go to my process here. Well, it's hard to say because it's divided by so many processes, but I'm maxing out the CPU. Now, if you're CPU bound, you can use a hog chop, and if your frame rate changes when you turn on the hog chop, you know you're CPU bound. So let me just bring up this thing again. There we go. And the hog chop, it basically just hogs some CPU cycles. So by turning this on, I dropped a whole bunch of frames. So I know that I'm CPU bound. By adding a little bit more CPU, I'm dropping frames. So that's an easy way of finding out if you're CPU bound. And to find out if you're GPU bound, what you need to do is usually resolution can tell you. So most of the time, your GPU, in typical situations, your pixel shading in your GPU will be the bottleneck. And in that case, if you lower your resolution and your frame rate goes up, you know you're GPU bound. Now, there are some cases that you might be using a lot of vertex shaders if you have special GLSL shaders, and that might be the reason. But most of the time, it will be because your pixel shaders are full. So let me just make something heavy here. Okay. Let's try to get this GPU bound and show what I mean. So one interesting thing you can do with tops, if you want to know the maximum resolution of your GPU, you can put in any number over 32,000 because the biggest available right now is 32,000 and whatever, and it will give you, that's the maximum resolution, 32768. I put in 38 and it only goes up to 32,768. Now that's about the same as, well, how many is that? That's 3840 times 8. Okay, that's more than 8. So we have 8 here, 8 4K screens in noise, and it's still not hitting my frame rate. Okay, I know how to make it. So the noise, if I wanted to make this not monochrome noise and RGB noise, now I'm doing it 3 times. So I'm using 3 times as much, and aha, my frame rate went down. And if I look at my GPU, okay, now I'm using up most of my GPU. So if I change the resolution of this and reduce it, and it goes down or speeds up, then I know I'm GPU bound. So if I go 1080, okay, so I was GPU bound there. Now, what's interesting is if I'm GPU bound and I turn on the hog chop, oh, it actually does make a difference. I didn't expect it to touch it at all, but it makes a little difference, but not that much. It's not really the GPU, the CPU that is a problem right now. So that's just a quick way of finding that out. So the other things in tops that take a lot of, let's say, juice, I'll call it GPU power. I'll just move this out of the way and plug this in. There's a few things. So other than the resolution, also your pixel format. So right now I have an 8-bit, an 8-bit fixed pixel format. If I go here and say 32-bit float, that will not only use a lot more GPU, but it'll use a lot more memory as well. So let me get the probe. Okay. So you can see here that as I increase resolution, let's make this 4K squared. They're all going to cook a little harder, obviously. And when I go from 8-bit fixed, the cooking isn't such an issue, but the memory, if I change this over to GPU memory and change it to 32-bit, you can see they all go orange. And instead of each one is now 128 megabytes instead of 31 megabytes. All right. So other things that in some operators, the actual operator will use more power. Like if I change the blur tops filter size, for example, that is something that will definitely cause more GPU load. So right now this is at 0.1 and 0.4, but filter size is very sensitive. So now it's taking 3 milliseconds on the GPU. So that is one operator where the settings make quite a difference. Another operator where it makes quite a difference is in the noise. As I showed you, monochrome versus RGB is 3 times versus 1 noise layer. It's 3 noise layers. And on the output page, you can also have the alpha be noise as well. So you could, depending on your settings, increase the load by quite a bit. And also in noise, something that is basically how many noise functions it has to calculate is their harmonics parameter. So if I go down to 1, this is 1 layer of noise. Harmonics 2 is actually 2 layers, so it's twice as heavy. And if you went up to 10, you get quite a heavy thing because it's calculating 10 noise functions at the same time. Okay. And there's also some other tops that are just heavy and you should know about, and that would be the SSAO top is a very heavy process. I see this in a lot of tutorials out there because it looks great, but unfortunately, it's rather heavy. It has to be after a render top, so I don't have that here. But and also the flex and the flow operators are pretty heavy, so they're a whole system for NVIDIA particles and flames. So what else? The other thing I'd like to talk about is if you start running out of GPU or CPU power, one thing you can do is run multiple processes. So this is a script, for example, here, where you would set the program you want to run, which is TouchDesigner, and then 2 different TOE files or projects. In this case, if you wanted to just open 2 on the same GPU, you'd get them both running in their own process, so you separate the CPU workload. If you have multiple GPUs in your system, you can use GPU affinity to use GPU for monitor, to assign the playback TOE to the first GPU and the control TOE to the second GPU, so you can separate the GPU workload as well. Now, this is a bit of work, obviously, because you have to then manage sending data between the 2 processes. So you have to weigh whether it's worth it or not. It's a little bit of refactoring. But for example, I have created in here this launch show, and I'll just open it and edit it. Here I'm going to use TouchDesigner 2020, 27390, and I only have one GPU, so they're both running on GPU 0, and I'll open a control scene and the SceneChanger perform, which we're going to go into in the next section of this workshop. So if I launch that, it's going to launch two processes, and they're totally going to be separate. Okay, this is its own process here, and this is the rendering process, and this is just the controls, and I'm sending it over, OSC, and it doesn't look like it's working, probably because I have something running in the background. But the point is, why isn't that working? That's funny. It's probably because I have the other process grabbing the OSC in the background. But that's a way of getting two processes on the CPU separately. So, and I'll show you how to set that up later this afternoon. Another way of doing that now is with the engine component. I don't have too much time to go into the engine component today, but here's an example of a heavy particle system that I made here. It takes about 7 milliseconds or 2 milliseconds on the GPU, 7 on the CPU. You can see that when I turn it off, our frame rate is really good here, and then it drops by quite a bit. Okay. So here, what I've done is I've saved out this component and then loaded it into the engine, the engine component, and this will process this entire thing on its own process. So let's turn this on and then turn on the power, and you notice that it didn't change the cook time up here very much at all. And if we look at the task manager, and go to TouchDesigner now, if you open it up, you'll see it's running a touch engine process in the background. So every engine component will run on its own process, and this is a way of dividing the work between different CPU threads. Now, right now, the engine component runs on the same GPU as the host process, but we're currently in development working on being able to select your GPU in a menu, so you sort of have the same GPU affinity, but for the engine comp. So that should be coming soon. So what I'd like to do now is, that's sort of like a summary. I was going to talk about perform mode, but I think most people know about perform mode. It's a good thing to use, but I want to jump into a real world example here. So I'm going to close down this project, and what I want to do is look at a project that is very, lots of people have found this because it's a cool effect with your Connect. It's called Particle Rain, Connect with TouchDesigner, and it's by Indai Huang from Hong Kong. And it's old, it's 2016, but everyone gets this file, and I noticed on some machines it doesn't run well, especially like small laptops really struggle with it because of some of the stop cooking. So I thought what we'd do is take this and see how much we can optimize it. And I've included it in the folder. Where did my folder go? Here we go. So it's Particle Rain here, and the one without any numbers on it is the raw file that I'm gonna use here. So. Okay, so we're going to go into project 1 here, and instead of selecting the Connect from a different, it used to have it selecting it here, I'm just going to put in a new Connect Azure top here because I have my Connect Azure here. Now, if you guys don't have a Connect, what I have done is I have included a little recording of myself in my Connect movie. You can drop in here and use in its place. sorry. So you can just drop it in and it'll play back a little loop. So whatever you need. And I'm just going to plug this into here. And all right. And I see it's not working correctly. So let's just jump in here and see what's going on. So the chroma key setting isn't right. Let's just, okay, that's about right. Good enough. 8.9. Okay, so we have it sort of working, and let's turn on the rendering at the end of here. All right. So all these particles sort of sit up on my shoulders and on my head and sort of have this glowy feedback effect. It's a pretty fun little effect. Let's grab the stats TOX that I have. So we'll go in here into TOX and bring in the stats and have it floating. So our current frame time is 29, 28, around 30 milliseconds. All right. So we're not at 60 frames a second. That's the first problem. Let's see what we can do to improve this. So I'm going to open up the probe again. And if I hit probe, okay, there's the project we're in. Okay, so this is the probe. Don't worry about that one. But down here, right after the connect, we can see this base comp and this SOP here. This is pretty heavy. So let's go down and look at that stuff here. All right. So if we dive inside, these tops are all fine. This isn't too much. But this one here, this first SOP is taking 4.5 milliseconds to cook. So that's really heavy. We need to improve this somehow. Now the trace SOP, just trying the parameters. Let's just throw down an info and turn on cook time. Okay. The trace SOP, these parameters don't make much of a difference. The biggest difference in the trace SOP is actually the resolution of the image you're tracing. And right now it's 640 by 576, which isn't that big, but because we just need to get an outline, we can actually reduce that quite a bit and probably get better performance. So let's move these over. And I will put down a null first and put a null there so I can put a resolution in between. Where is it? Okay, so what I'm going to do is look very carefully at this and see how it changes when I change the resolution to maybe half. So even at half, it looks pretty similar, but the cook time, look at that, 1.5 instead of 4.5. And it looks very similar. So we could even try quarter. Now quarter starts to get a little noisier. I don't know if that would affect the final look or not, but it is kind of jittery. So I'm pretty satisfied with half, and we only have a 1.4 millisecond cook time instead. So let's go with that. Now resolution is also a good trick when you're doing a blob track top or a blob track chop. Those are also operators that are very sensitive to the resolution. So something to think about when you're using the blob trackers. Extrude. Not too much we can do here. It's just doing its thing, extruding. It takes 1 millisecond, but there's nothing we can really optimize here. The resample, let's see what the resample is doing. It's taking 0.4 milliseconds. It's doing a level of detail, but to be honest, it's not doing much. Like if I bypass this, I don't see any difference. So you know what? We can delete that safely, and it's not making a change. All right. So if we go up a level now, this base is now taking 2.5 milliseconds. So that's a lot less than before. It was over 4. All right. So let's now look at these. Why is this guy upside down? Let's home it. Okay. Let's take a look at the poly reduce. Polyreduce is taking 1 millisecond to cook. It is currently keeping 39%. Well, what does it actually do to the output, though? Again, this is something that might have been an experiment or he was playing with, but in the end, it's not really used to change it at all. So let's delete that as well. Now the transform chop, what's this guy doing down here? Okay, so there's a geo, he's not doing anything, but let's just clean it up. We don't need him. Now this transform, remember what I said earlier, we'd like to not transform in SOP space if we could, but I think this transform is going into particle SOP. It is. Let's move these up. And it's being used for the particle SOP's surface attractors and collision. So here's the thing, if we need to move it in the SOP object space, if we want to see if we move this, let's just see, it's actually moving with respect to the emitter in up here in the particle SOP. If we were to move it at the geometry level, let's just do that. We'll change this component type from a base to a geometry. And I guess we need to turn on the display flag. Okay. Now, if I move this here in the geometry, it's moving the whole thing up in world space. So the renderer would see it change, but it doesn't move it in respect to the particle SOP's object space. So that's not going to do it for us. So we kind of have to move it in SOP space, unfortunately. But what we could do is check this out. If we go inside here, remember we extruded this. The extrusion caused our points to increase because we're now making deep geometry. So we have about 1,000 points versus the trace, which only has 300 or 250. So if we could do the transform here on 250 points, it would be a lot better than doing it on 1,000, right? So let's go up. Now, before I change this, I just want to take a look at it carefully. So if I take a side view, it goes from 0 to about 0.6. If I go, just to see how thick it is, all right? If you want to see the different views in a viewer, you can press 5 and get all of them. Home. Number 1 up here, the first quadrant, hotkey 1 is the top view, and then 5 to go back. Number 2 is the perspective view, hotkey 2, and then hotkey 5 to go back. Front is 3, side is 4, all of them is 5. So I don't know if people knew that, but so let's cut this, or I'll just bypass it for now, and copy it, and we'll put it in here. Okay, see, that cook time is a lot less. Instead of 0.4, it's 0.16 or 0.2. So we've almost half that cook time, better than half. I need to home these. I don't use adaptive homing, so I have to home them when I scale them. Now we notice though that because we scaled up before our extrude isn't as fat as it used to be. If we look at it from the side, it's only that. So we need to change the extrude parameter to make it deep again. So let's bring this up to about 0.6. And then we should have a pretty similar look to what we had before. Okay, great. And we can get rid of this transform. That's pretty good. I'm going to put a null here just because I like my wires to be like that. So where are we now? We're from 30 milliseconds down to 20. That's pretty good just by addressing the geometry creation before the particle SOP, right? So that's not too bad. Let's look at what should we attack next. If we look at this whole chain up here of SOPs, There's a lot of cooking there. Some of it's necessary. The particle sop we can't get around because it's creating particles, but we can, let's look at these guys up here. So we have these five sops before the particle sop. A grid, a noise, and a point, which is doing adding tension and changing the normal, affecting the normal, which has to do with the way the particles will be created. So we want to keep that. Then we have a transform, which is statically moving it up in Y. So we can see that if we do this, we move the grid, okay? Pretty basic. And then we have a sort, which is doing a random point sort so that the particles are created from random positions instead of in the order of the point numbers. So again, pretty standard stuff. But this noise here, whoops, is forcing all of these downstream to cook. And technically, the point, transform, and sort don't need to cook every frame because those are just static things that we're doing to the geometry. So if we were to move those out and put the grid right into them, whoops, don't do it like that. Put the grid right into them. And then after the sort, go into the noise. Now what we have is this same result. You can see that we have this noise grid making particles in the same way, but all of these are not cooking. Static, static, static. They'll only cook if we go back to the grid and make some change, like number of rows or whatever. But the noise is right before the particle, so we've optimized that a bit. Not a huge difference, but it can make a little bit of a change. So we always looking for any milliseconds we can here. All right, what else? Let me see. Let's clean up this stuff over here before we start attacking it. I'm going to move the textures down towards the material. This is the material that they're assigned to, so I'll just put them there. And I'll just move my lights over together right by the render. I like to put them. And okay. So I guess the big one we have to consider now is the point stop here. This one is taking 4.8 milliseconds. It's massive, almost 5 milliseconds. And then the geo, it's not too bad, but now the point is adjusting the color of these particles. And what is going on here is he says 1 minus the life. So they start out with an alpha of 1. And then as the particle gets older, it subtracts from 1, so the alpha goes down. So as these particles get older, they become more transparent, basically. Now, doing this to 3,000, how many points are there? 3,000 points is not going to be fast. Assigning an expression to 3,000 points will just be slow in SOPs. And he's also, in this case, using TScript, which I don't want anyone here to have to go and learn. $life is a TScript way of accessing the life attribute. So how else could we do this? Well, whenever there's a lot of points and particles and you want to render them, you should always think about GPU instancing. How can we use instancing in Touch to do the same thing? So let's think about that. I'm going to start out a little instance. I'll leave this up here, but I'll start out an instancing setup. We'll use a rectangle for our point sprite and a new geometry component. Okay, that's a huge point sprite. So let's make it small, maybe 0.1, just to get something in there. You know what else I'm going to do? I'm going to go and check out this base 2 where this feedback is happening, because I'd like to find out if I can make a reset button so we can clear it out when we're doing this work. So let's go into base 2 and see what's going on. Home. Okay, just a little cleanup here. Home again. It seems like this branch was an experiment. It's not being used, so we'll just delete that. And this stuff is all good. You can't really optimize that. So what I'll do is the feedback here, we don't need two views. Let's just get the final view. The feedback here has a reset button, so you can reset the effect anytime you want. So let's put that on the top of this component so I don't have to dive in here every time I want to reset it. So I'll just say open parameters here. And I'll go up a level. And here I will right click and say customize component, and I can just drag that pulse into this dialog and select bind it as new master, which will automatically connect it. And now I have this custom parameter. I can close this and I can reset it from outside. So that's a lot easier when we're developing at this level. We don't have to dive in every time. And we'll call this feedback because that's what it does. Okay. So back to our instancing. Let's set this up really quickly. We'll go to the instance page of this little guy and turn on instancing. Now, as of the 2020 builds, you're able to use any operator for any one of the instancing attributes. So I can use, I can use the position directly from this particle SOP. So that's what I'm going to do. I'm just going to take it here, particle SOP, and I'm going to select the X, Y, and Z. Okay, so that's working. It's a little hard to see. And that's why I wanted this refresh. Okay, reset. I'll just turn off the render for now. What we need to do is we need to figure out the material, don't we? So I'm going to turn this off for now. Okay, there we go. And instead of using a point sprite, we need to use just a regular material. So let's use a constant. That's fine. Okay, and we'll apply the constant to this guy. And then I'll apply the same texture to the constant's color map. So we basically have the same thing happening. Wow, I need to reset that. Okay. Reset. Okay, so something's happening now. Let's take a look at the point sprites settings. The alpha was 0.465, so let's copy that, 0.465. This is just a little bit of setup. And then let's check on its common page. Of course, there'll be some blending here, and 1 and 1. Blending and 1 and 1. Okay, that's interesting. So we'll turn on blending and change the destination color to 1, just to have the exact same effect here. And anything else different? Yeah, the depth test he turned off. Okay, we'll just do a 1-for-1 setup so it looks a little similar. Okay, starting to get there. Now what we need to do is replace what this point SOP is doing. And that is the life stuff. So let's, from the particle SOP, let's look at what life is. And one way, I'm going to pause the timeline here. One way of inspecting particles or any geometry in SOPs is to use a SOP to DAT. Okay, and a SOP to DAT will basically give you all of the geometry attributes. So let me just open this as a viewer. All of the geometry attributes of this SOP. And the reason I paused the timeline is this table is so big because there's 3,000 points, it cooks rather slowly. But you can see here that we have position and velocity, and here's the life that we're interested in. Drag, normals, everything in one table. This is like Houdini's geometry spreadsheet, for example. Okay, so here in the life, you'll see that there's two life attributes, life 0 and life 1. Now, life 1 is the total lifetime of the particle. So if we look at the particle settings, the life expectancy is 10. So all of the particles are going to have a lifetime of 10 plus or minus the life variance plus or minus 0.5. So you'll see, 9.5 to 10.5 basically. The life 0 is how long that particle has been alive for. So how long since its birth has it been around? It's going to count from 0 up to this number, and then it's going to die. So this is really interesting spreadsheet to kind of look at when you want to see if something you've set, like if you do something in a point stop, something you've set is working, or if you want to do any debugging of your geometry, it's quite useful. Just turn off the viewer when you don't need it, because as you can see, it's really heavy to draw that viewer. So let's do some instancing in chops here with that life parameter, a life attribute, I should say. It's not a parameter, it's called an attribute. So the SOP here is looking at the position XYZ. I can turn that off because I'm doing position directly from the particle SOP. And I can go down here to custom and type in life, which is the name of that attribute, and I can get life 0 and life 1 as channels. And if we look closely, you can see here is the life expectancy from 9.5 to 10.5. It's all random. And then here is the actual life of those particles. It's going from 0 to the end of their lifetime. Okay, so let me just take a look at this, my note here. So I think the first thing we want to do is we want to get this value in between 0 and 1, because alpha is 0 to 1, right? And this age right now is 0 to 10. So if we take how old someone currently is, if I'm currently 5 seconds old, out of my total lifetime, which is 10, I go 5 divided by 10, I'll get 0.5, which is approximately halfway through. So if I can divide these channels, then we'll get it in between 0 and 1, how old the particle is. So let's put down a math chop and say combine channels, divide. So now we have basically a percentage in between 0 and 1, or a fraction of how close they are to death, or how long they are along in their lifetime. Okay, so we can connect this right away before doing anything else. We'll do a null. And we want to take this into the instancing alpha. So that's on instance 2 page. And we'll go to the color up here, null 3. And right here, we'll select life 0. So let's reset that feedback and see what's happening. So what's happening here is it's working, but the alpha starts out as 0 when they're born, and then towards their end of their death, they become full alpha, full 1. So we want to invert that. We want to actually have the alpha fade off as they get older. So we want to reverse that. We have to do up in here in this, we have to do the 1 minus part, right? So for 1 minus, there's a nice little trick here with a pattern chop you can use. So insert a pattern chop here. And we want the value of 1. So select constant, and the amplitude is 1. So this is a value of 1. And the pattern chop takes its input as the length. So it's the same length as this guy. And instead of having a chop channel just by itself, on the channel page, you can choose to append it or insert it. Insert will put it first. So let's insert it. Now we have 1, channel 1, above life 0. And now we can just use a math chop to subtract, which is nice and easy and all in chops. So let's subtract. And that basically does 1 minus life. Okay. And now we can see they start out with their alpha, and as they go down, then they slowly fade out. And if we want to get it exactly the way the previous setup had, it's times 0.95. So we can take this math and put in times 0.95. Okay. And what's this complaining about now? Okay, the channel name changed. Chan 1 is now the channel, not life 0. So it couldn't find life. So we have to fix that. Okay, it's now Chan 1. Okay, that looks better. Now it's actually working. Reset. Okay. So let's just do a litmus test to see if this is sort of the same look as before. We'll turn off this render and we'll turn on the original one. Really close. Now you might want to play with the materials a little bit, the point sprite versus the constant. You might want to change the alphas a bit to get the exact same subtle effect, or the size of the rectangle here for the point sprites. But for all intents and purposes, this is really close. So we can delete these really heavy guys here. Okay. And now look at our frame time. So our frame time is now around 60 milliseconds, almost at 60. And I wonder if I just turn off a couple viewers. Yeah, I can get to 60 frames a second. So we took something that was starting at 30 milliseconds or so and got it down to about 13 or 14. Turn that off there. Now, if I go into perform mode, let's see what it actually is. So we got it from whatever it was before down to 5 or 6 milliseconds in perform mode for the same project. So it just goes to show that, you know, if you spend the time in optimizing, it's almost like buying a new GPU and saving a lot of money. So, so that was a pretty good example of how we can get that. Now let's go back to the original one and just see what it was doing in perform mode. Whoops, sorry. I think this one I have fixed up to work as original, but I've included the connect. So I'm just going to stop that one from cooking. Okay, let me just... Give me a second to find my movie. And plug it in. Okay, and F1. So this one in perform mode was doing about 20 milliseconds. Yeah, 20 milliseconds. So not quite at, it's about 40 frames a second on my machine, and my machine is pretty beefy. So that's what it was before. And now we're at 6 milliseconds. So lots of room to play with. You could increase the particle counts. You could do 2 characters instead of 1. You could do a bunch of stuff. So any questions on, let me think, do I have anything else to mention about this? No, I think that's all I wanted to show for optimizing this. Any questions about this, or we can have the next break now, and then the next topic I'd like to start fresh instead of starting now.